Imagine, for a moment, that you're standing under a starlit sky. The night is calm, and as you look up, you marvel at the sheer vastness of the universe, stretching beyond the limits of human comprehension. Now, imagine that this vast, dark expanse is filled with not just stars, planets, and galaxies, but with mysterious, enormous structures that seem to defy everything we thought we knew about the cosmos. It's hard to grasp, isn't it? But recently, scientists made a discovery so astonishing it has shaken the very foundations of our understanding of the universe. They've found a gigantic, ring-shaped structure in space, a massive formation of galaxies and galaxy clusters that spans an unfathomable 1.3 billion light-years. This colossal formation has left astronomers astounded, as it challenges many of the core principles that have guided our study of the cosmos for decades. This newfound structure, aptly named the Big Ring, is not just another cosmic anomaly, it is a breakthrough discovery that could potentially rewrite the very rules of cosmology. It's the kind of discovery that makes you pause and rethink everything you've ever heard about the universe. The size alone is almost beyond comprehension. But what really makes it such an exciting, if somewhat unsettling, discovery is the fact that this enormous ring pushes the boundaries of what we consider possible in the universe according to current scientific theories. Scientists had assumed that on the largest scales, matter in the universe is distributed evenly, smoothly, like a chocolate bar, where all the ingredients, from small sugar crystals to large chunks of nuts, are spread out evenly throughout the bar. The idea was that no structure could be large enough or dense enough to break this cosmic symmetry. But then came the Big Ring, a structure that defies this expectation. In astronomy, we've always worked under the assumption that the universe follows certain predictable laws and principles. One of the fundamental ideas behind modern cosmology is known as the cosmological principle. This principle essentially states that, on the largest scales, the universe is homogeneous and isotropic, meaning that matter is distributed evenly across space, and there are no large, unnatural clumps or voids. In simple terms, imagine the universe as a giant chocolate bar. The chocolate itself is smooth, and the sugar and nuts are scattered evenly, with no major clumps in one area. But then, along comes the Big Ring, and it's like discovering that there's a giant pile of nuts all in one place in the middle of the chocolate, with the rest of the bar being made up of almost no nuts at all. It completely breaks the idea that the universe should be smooth and evenly distributed. The existence of such a massive structure seems to fly in the face of everything we've come to understand about how the cosmos should behave. Now, let's dive into the discovery itself. The Big Ring was spotted by astronomers from the University of Central Lancashire, led by Alexia Lopez, a brilliant PhD student who's known for her knack for finding massive, unusual structures in space. The team's discovery of the Big Ring has left the scientific community stunned, and for good reason. To fully grasp the significance of this structure, we must first understand what makes it so remarkable. The Big Ring is composed of multiple galaxies and galaxy clusters, and the size of this formation is staggering. Spanning 1.3 billion light-years, it's so large that it cannot be observed directly with the naked eye. Even with the most advanced telescopes, this colossal formation remained hidden from view for a long time. It wasn't until Lopez and her colleagues carefully mapped the distribution of galaxies across the universe that they began to uncover this truly massive structure. So, how did the team find the Big Ring? The discovery wasn't the result of a targeted search for such a structure, it was more of a happy accident. Lopez was actually working on a completely different project when she stumbled upon the data that revealed this enormous formation. Her work had initially focused on understanding the distribution of galaxy clusters, but as she pieced the data together, she noticed something that couldn't be ignored. There, in the data, was a massive structure stretching across an enormous swath of space, one that no one had ever seen before. As astronomers scrutinized the data, they realized they were looking at a gigantic ring of galaxies, unlike anything ever discovered in the universe. What's even more fascinating is that this isn't the first time Lopez has uncovered something extraordinary in space. A few years earlier, she had also discovered the giant arc, another massive structure that spanned an incredible 3.3 billion light-years of space. Lopez's ability to spot ultra-large phenomena has earned her a reputation in the astronomical community as an expert in discovering the largest structures in the cosmos. However, despite her expertise, Lopez herself admits that even she doesn't fully understand how these gigantic formations came to exist. Their very presence in the universe is something of a mystery, and they challenge our current understanding of cosmic evolution. One of the reasons the Big Ring is so perplexing is that structures of this size simply shouldn't exist according to our current cosmological models. If we look back at the cosmological principle, we see that it suggests matter should be distributed uniformly across the universe. According to the theory, large-scale structures should follow this pattern, and any deviation from this would be considered highly unusual. Yet, the Big Ring is a striking violation of this principle. Its sheer size and the concentration of galaxies in one area are so extreme that they should have created noticeable ripples in the cosmic microwave background, CMB, radiation, an ancient remnant of the Big Bang that scientists used to study the early universe. But when astronomers looked for evidence of the Big Ring in the CMB, they found nothing. The discovery of this gigantic formation doesn't fit neatly into any of the existing models we use to describe the universe, and it raises more questions than answers. The fact that the Big Ring contradicts the cosmological principle is significant because it challenges the very foundation of modern cosmology. For decades, astronomers have believed that the universe is smooth and homogeneous on the largest scales, with galaxies and galaxy clusters arranged in a way that follows a predictable, orderly pattern. But now, the Big Ring is forcing scientists to confront the possibility that our current theories may not fully explain the complexity of the universe. This realization is not just a minor inconvenience, it could be a game-changer. If the universe is not as smooth and uniform as we once thought, then many of the calculations and predictions we've made about the structure of the cosmos might need to be re-evaluated. But where did the Big Ring come from? How did such a massive formation of galaxies and clusters come to exist in the first place? Scientists don't yet have all the answers, but one possibility is that the Big Ring may have formed through a process known as gravitational attraction. This is the same force that keeps our planets in orbit around the Sun and causes galaxies to form and evolve over time. It's possible that the galaxies within the Big Ring were drawn together by their mutual gravitational pull, eventually forming a structure so massive and so concentrated that it defies our understanding of how the universe works. However, this explanation is still speculative, and further research will be needed to determine how exactly the Big Ring came into existence. To add to the mystery, the Big Ring is not the only unusual structure in this part of the universe. The same region of space also contains the so-called Great Void, a vast, empty area that stretches for 330 million light-years and contains only a handful of galaxies. This void is another anomaly that challenges our understanding of the cosmos. According to current cosmological models, such enormous voids shouldn't exist. The laws of physics dictate that there should be a certain amount of matter scattered evenly throughout space, and these vast, empty regions defy that expectation. Yet, the Great Void exists, and it seems to be intricately connected to other massive structures in the same area, including the Big Ring. Interestingly, both the Big Ring and the Great Void are located near the constellation of Boötes, a region that has long been known for its strange and unexplained features. It's possible that these two phenomena are somehow related, or that they are part of an even larger cosmic structure that we've yet to fully understand. Some researchers even speculate that the Great Void and the Big Ring could be the result of some kind of cosmic interaction, perhaps one that is related to the expansion of the universe itself. As astronomers continue to study these enormous structures, it's becoming clear that we are only beginning to scratch the surface of understanding the true nature of the universe. The discovery of the Big Ring and other similarly large structures challenges the very laws of physics that have guided our understanding of space for centuries. It's possible that these structures could form an even larger cosmic entity, one that we've never been able to detect or measure before. But what does all this mean for our understanding of the universe as a whole? The Big Ring, the Great Void, and other massive structures challenge our current theories, forcing us to confront the possibility that our understanding of the cosmos is far from complete. Perhaps we've been looking at the universe through a narrow lens, focusing only on the aspects that we can measure and quantify. But as scientists begin to explore the mysteries of these vast, unimaginable structures, they are starting to realize that the universe is far more complex and chaotic than we ever thought possible. This realization could have profound implications for how we view our place in the cosmos. If the universe is not as smooth and predictable as we once believed, then we may need to rethink some of the assumptions that have shaped our understanding of the cosmos. Could it be that we are living in a universe that is more organic and chaotic than we've ever imagined? Or is it possible that the structures we are discovering are just the tip of the iceberg, and that there are far more massive, enigmatic formations waiting to be uncovered? The implications of these discoveries are still unfolding, and much more research will be needed to fully understand the true nature of the universe. But one thing is certain, the universe is far more mysterious and complex than we ever imagined. As astronomers continue to explore the vast expanse of space, we can expect to see even more groundbreaking discoveries that will challenge our understanding of the cosmos and push the limits of human knowledge. For now, the discovery of the Big Ring has given us a glimpse into a universe that is far beyond our current comprehension. It's a universe filled with wonders, mysteries, and structures that defy our understanding of the laws of physics. And as we continue to explore this vast and uncharted territory, we are bound to encounter even more astonishing discoveries that will challenge everything we thought we knew about the cosmos. The journey of exploration is just beginning, and who knows what we will find next in the incredible, infinite universe that surrounds us.